Hello everyone, welcome back to my channel. Today I am going to start with the next exercise of the chapter differentiability. Before starting this exercise, we will discuss about the Rolle's theorem. What is Rolle's theorem? So now let us start with the Rolle's theorem. Firstly, we will define the statement of the Rolle's theorem. It is a function f of x defined on AB is such that, firstly, for proving the Rolle theorem, we will have to prove that f of x is continuous in closed interval AB. Then second, we will have to prove that f of x is derivable in open interval AB. And third is, we will have to prove that f of A will be equals to f of B. Then there exists at least one real number C which belongs to AB such that f dash of C will be equals to 0. So this is the all about the Rolle's theorem. If function f of x is defined on the interval AB, then such that we will have to prove that f of x is continuous in closed interval AB, and then f of x is derivable in open interval AB, and f of A will be equals to f of B if there exists at least one real number C which belongs to AB, such that f dash of C will be equals to 0. Now let us start with the exercise 6F. Now we will start with the first question related to the Rolle's theorem is, verify Rolle's theorem for the given function f of x will be equals to x plus 2 into x minus 6 in the interval minus 2 and 6. Here function f of x is given that x plus 2 into x minus 6. Now this is a polynomial in x. So firstly we will prove for the continuous. So we know that every polynomial in x is continuous for all x. So therefore f of x is continuous in minus 2, 6. Now we will find that f of x is derivable in open interval. That means we will have to find that f dash x. So we will find the derivative of this term. That means f dash x. It will become, if we will solve this, it will become x cube minus 6x plus 2x minus 12. That means x cube minus 4x minus 12. So the derivative of this will become 2x minus 4, which exist in open interval -2, 6. So therefore f of x is derivable in -2, 6. Now third, we will have to prove that f of a will be equals to f of b. That means a and b is given. So firstly we will find for -2. So we will put the value -2 here. It will become -2 plus 2 into -2 minus 6. It will become 0. Then we will prove for f of 6. That means we will put here 6. That means 6 plus 2 and 6 minus 6. It will also become 0. So f of -2 will be equals to f of 6. Therefore f of x satisfies all the conditions of Rolle's theorem. So therefore there exists at least one value of c of x such that f dash c will be equals to 0, where -2 is less than c is less than 6. Now for f dash c will be equals to 0, we will take this term. Here we will put x will be equals to c and this term will be equals to 0. Then it will become 2c minus 4 will be equals to 0. That means c will be equals to 2, which belongs the interval -2 and 6. So therefore Rolle's theorem is verified. Now second question is verify Rolle's theorem for the given function f of x will be equals to e raised to power x into cos x. Here f of x will be equals to e raised to power x into cos x. Now for the Rolle's theorem, firstly we will prove that function f of x is continuous on the given interval. For this, if e raised to power x and cos x are the continuous function in the given interval, therefore e raised to power x cos x is also product of these functions are also continuous in -π/2 and π/2. Now secondly we will prove for f of x is derivable on the open interval this. So for this, firstly we will find f dash x. That means the derivative of this term. It will become first derivative of second plus second derivative of first. It will become e raised to power x cos x minus sin x, which exists in open interval -π/2 and π/2. So therefore f of x is derivable on -π/2 and π/2. Now we will find for f of a will be equals to f of v. That means f of -π/2 will be equals to e raised to power -π/2 cos π/2. It will become e raised to power -π/2 into 0. That means it will become 0. Now secondly we will find for f of pi by 2, that means e raised to power pi by 2 into cos pi by 2. It also will become 0, so f of minus pi by 2 will be equals to f of pi by 2. So therefore f of x exists all the conditions of Rolle's theorem. So therefore there exists at least one value c of x in given interval minus pi by 2 and pi by 2, such that f dash c will be equals to 0. That means we will put there x will be equals to c, that means it will become e raised to power c into cos c minus sin c will be equals to 0. That means cos c minus sin c will be equals to 0. So therefore it will become cos c will be equals to sin c. That means sin c by cos c will be equals to 1. That means tan c will be equals to 1. For tan theta will be equals to 1, there exist 4 values of c, that means pi by 4, 5 pi by 4, 9 pi by 4 and up to so on. So here c will become pi by 4, which lies in the interval minus pi by 2 and pi by 2. So therefore Rolle's theorem satisfies. If you like my video, then please like, subscribe and share my videos, and do not forget to press the bell icon for the notification of the more videos. Thanks for watching.